Hello and welcome to episode 15 of the Minimapper series. Most of the content of episode 15 is in an article on my website. This video is basically just going to be a very quick demo of where I've got to with some of the STM32 software that I've been working on. And I've been doing quite a few things with this, and the biggest change I've made recently is that I've tried to set things up in a way so that I can test all of the software on Linux, as well as building applications for the STM32. And that's quite interesting. I mean, there are some nice C++ test frameworks and mocking frameworks, and I'm using one of each of those. But the bit that requires a bit of sneakiness is testing low-level hardware drivers, where you need to basically mock the hardware. And so I've done that, and you can read about that. Look at the code. Today, I just want to show a very quick demo of some of the software. So let's get to that. Okay, so you can see three things on the screen here. The first one is a terminal window that we'll come to in a minute. The second one is the software side of the USB oscilloscope we're going to use. And the other one is this camera view. And in the camera view, you can see the STMicro Nucleo board, which has the STM32 processor on it. And you can also see here a Digilent Analog Discovery 2, which is a USB oscilloscope and logic analyzer and other things. And both of these things, the Nucleo board and the Analog Discovery 2, are connected to my PC via USB connections. And so on the Nucleo board, the way this works is that one of the UARTs on the STM32 goes via the ST-Link debugger here and is provided to the PC as a virtual USB serial port. And we're going to talk to that in a minute. The Analog Discovery 2 is connected to a couple of pins on the Nucleo board. There's a ground connection here, the green wire, and the red wire connects to a GPIO from the STM32 that has a timer channel as its alternate function. And we'll drive that with a PWM signal in a minute. So first of all, let's look at the serial terminal here. And this thing is it's connected to this USB port on the serial port on the STM32. And the STM32 is running an application that provides a couple of command shell modules for doing things. And the first one is a Blinky module, so we can do things like, say, LED 1 on, and that switches on the LED here on the STMicro. We can see LED 2 blink, and you see it blinks on and off. We can have the third one blinking too, and we can set the what's it called? Delay 1, 2. Yeah, we can set the blink rate for these things. So I mean, there's nothing much to this, obviously, but there's quite a lot going on in between typing stuff in this terminal window and those things happening on the Nucleo board. And like I said at the beginning, I'm not going to go over all of this in this video. There's an article that describes some of this stuff, but basically there are some layers of software. There's a UART driver, there's a terminal abstraction that allows you to have some kind of line editing like this. And then there's a command shell that you can extend by writing modules for. So this application has two command shells built into it, this LED blinky one, and it also has one for doing PWM. So if we switch the PWM on and then set the duty cycle to 50%, and then we go to our USB oscilloscope thing and we start it up. So this is connected to pin 0 on the Analog Discovery 2, which is the channel that's going to this GPIO on the Nucleo board. And then we can fiddle with the duty cycle on this. So there you go, 25%. Oh, I seem to have it upside down. So we can set the polarity to positive. So you can see it's 25%. And so the point of this is that having a command shell like this that you can use to connect to hardware resources on your development board makes it really easy to test things and develop things. So as well as running unit tests on Linux, which is one of the main things that I've done with the software changes I've made, it's also easy to build a command shell application that you can then mess around with this stuff. So this doesn't look like anything very impressive, I know, but there's a bit of stuff going on behind here. The next thing I'm going to do is take that PWM driver and put it together with some other stuff to make a whole motor driver. And then I can assemble the motor prototype board and start playing with it. I'm working on the Link 434 communication stuff in parallel with this, both hardware and software. And I'll talk about that again soon. Anyway, thanks for watching. See you next time.